So today we're going to discuss about the implementation of multiple sampling rate, that is sampling rate conversion using Matlab. So far we have learned what is the decimation, what is an interpolation, and how are we going to be performed with the rate of conversion. And if the rate of conversion is of both the decimation and interpolation factors, they are all co-prime, what is the possibility we could able to perform interchangeable and check the validity of the interchangeable property to check whether the rational futures of I by D or D by I is being continuing. But the problem what we could able to be inferred in the analysis of the entire sampling rate conversion is nothing but the rational factors is okay when we go for a lower range, but when we range of the decimation factors as on high, the interpolation factor also subsequently increases, then that is the problem where we need to kindly look into it. So to overcome or to visualize it, when the interpolation factor is more than the decimation factor, what is the influence we are going to able to be observed? And at the same time, if the interpolation factor is less compared to a decimation factor, what is the significance of the waveform which will be inferred? And all these things are to be observed practically rather than applying the theoretical view onto it. So this particular session is mainly give an insight to how are we going to be incorporated on this into a Matlab window or a Matlab code, and we will try to demonstrate the application of source by using a code, and this code will demonstrate the effect of will be seen the effect of sampling factors, and that is what we are going to infer in this Matlab code, and followed by we do have the analysis with respect to the simulation. So here is the programmatical view of this. It talks about what is the input signal and what is the rate of conversion we are going to be performed. And here the rate of conversion I have considered here is with the decimation factor of 4 and the interpolation factor by a factor 5. So the rational factors of both the I by D. So far we have used the term I and D. Here I use the term of L or M, where L represents here is the interpolation factor and M represents the decimation factor. So interpolation by a factor of I and decimation by a factor of 4. And we have to plot a signal, and then we need to understand it. How are we going to be find the rational factors? How are it is going to be affect with respect to the sinusoidal input signal? To generate a sinusoidal input signal, I need to give a frequency. I have given here as the original sampling frequency as 20, and then I need to be sampled at a regular time intervals. So to do that, I have given the sampling time period T is equal to 1 by F, and followed by at every of my input signal or the input signal frequency which will be sampled at this period, and the period is calculated by Tx, where x is nothing but 0.7 into sine of 2 pi Tx. So this is the original x of n. So normally till now we have considered the sequence in a discretized form. So x of n might be in the formation of 1, 2, 3, 1 and that digital sequence, but here we have represented it in a form of sinusoidal representation, and the signal will be repeated over the time interval or sampled at a regular interval of the value given as calculated by the Tx. And we do have the resample values. The resample value is going to differentiate or going to give the conversion rate by a factor of 5,4. So where x is the input sequence, 5 is the interpolated value, and 4 value is nothing but a decimated value. So all this will be given as a parenthesis for the given variable y. And now are we going to plot for the given time signal t of y. We need to plot it. So for that we need to see the vector at which the signal is going to be plotted. So if we see the length of y, what will be the length of y? The length is given by a rational factor of 5 by 4 along with the total number of the input sequence x. So 4 into tx divided by 5 will be given you the time vector at which the signal will be get overviewed. And then we can able to see to that how the original sample and the resampled sequences are being plotted, and with respect to their locations, with respect to their amplitude values can be plotted. The major section of this interpolation and decimation will be falls only in this area where we need to give the sampling frequency followed by sampling period, and then we need to generate a sine waveform, and then we recalculate it. So this is the Matlab code to represent this. And this is the pictorial sample output sequence which we generated for a given input signal. So this is a sinusoidal waveform, and this sinusoidal waveform is discretized at different intervals by a sample time tx, and then we sampled this signal for the given signal x of n as 0.7 into sine 0.7 sine 2 pi tx. For that the signal is being plotted. And the resampled sequences are nothing but which has been plotted by a circle 0, and that defines you that whether it is approaching or nearing to the criteria of a formation of getting the rational factor of n by 4. So all the signals which are very close to the rational factor of n by 1 are plotted with the blue and dotted lines, whereas the original signals as well as the resampled signals are marked with the different notations.